This lecture is somewhat of an aside, but it's relevant to what we're doing in Chapter 2.2, so I wanted to put it in this general area. So what I'd like to talk about is divisibility of numbers, because the quicker you can decide if a number is divisible by certain numbers, the easier it's going to be for you to do factorization and division itself. So first off, I'm going to just let you know that what I'm looking at here on the left-hand side of the screen are the Chapter 1 Carson notes. It's on page 25, and this you could find on the EVC tab, the Evergreen Valley College tab, the Evergreen tab, in the pre-algebra section. So with that said, let's go ahead and look at these divisibility rules. So first off, if a number is even, and even, remember, it means that it ends in a 0, a 2, a 4, a 6, or an 8, then you know it's going to be divisible by 2. So we know that 1298 or 1298 is divisible by 2 because it is ending in the 8 here. So let's check that out. 2 will go into 12 6 times, 2 goes into 9 4 times with 1 left over, and 2 will go into 18 9 times. So you see that this is indeed divisible by 2. Next, our rule is divisibility by 3. A number is divisible by 3 or divisible by 3 if the sum of its digits are divisible by 3. Now, digits is a word you should know what that means. Digit means the numbers that hold the place values. So 0 through 9 are the digits. So 348 is divisible by 3 because 3 plus 4 plus 8 is going to be a number that's divisible by 3. So 3 plus 4 is 7, and 7 plus 8, which is equal to 15. 15 is divisible by 3, therefore this number is divisible by 3. Let's check it out. 3 goes into 3 one time. 3 goes into 4 one time. 3 with 1 left over. 3 will go into 18 6 times, and there you see that it's evenly divisible by 3. Divisibility by 4 for any number that's greater than 99. If it ends in a 2-digit number that's divisible by 4, we know that it's divisible by 4. So an example of this would be 1024. 1024 we know is divisible by 4 because 24, the last 2 digits, are divisible by 4. So let's check it out. 4 will go into 10 2 times with 2 left over. 4 will go into 22 5 times with 2 left over. And 4 will go into 24 6 times. And you see, indeed, that it is evenly divisible by 4. Our next divisibility rule that's nice to know is divisibility by 5. We should already know this. If it ends in a 0 or a 5, it's divisible by 5. It ends in a 5, 1245, 1245 is therefore divisible by 5. Let's check it out. 5 will go into 12 2 times with 2 left over. 5 will go into 24 4 times with 4 left over, and 5 will go into 45 9 times. There we go, it's divisible. Next, we have divisibility by 6's rule. If a number is divisible by 6 if, number 1, it's even, and number 2, its digits are summed to a number divisible by 3. In other words, it has to be divisible by both 2 and 3. So 348 should be divisible by 6 because it is even. And 3 plus 4 plus 8 is 15, which is divisible by 3. This is the same example we did for divisibility by 3. So let's check it out now that we know that both of those are upheld. So 6 will go into 34 5 times with 4 left over. And 6 will go into 48 8 times, and therefore we see, yes, it's divisible by 6. Our last one is divisibility by 10. We know if a number is divisible by 10 if it ends in a 0. Let's check it out. It ends in a 0. 10 will go into 50 5 times, and 10 will go into 0 0 times. Bingo, it's divisible by 10. And those are your divisibility rules. They'll help you out in a lot of ways.